Hello everyone, in this video I will demonstrate how to deploy and use the ELK Stack in an AWS EKS cluster following the configuration in my GitHub repository. The prerequisites for this project is that you have an EKS cluster up and running without Fargate, as this configuration creates EBS persistent volumes, and those are currently not supported by AWS Fargate. So this is the architecture of the cluster that is up and running in my AWS to support a simple authentication API. This API will generate logs, and our ELK stack will capture those logs and allow us to visualize them in a centralized interface. The only remarks I have here is that the AWS Fargate profile will be deleted because, as I said earlier, this is not supported by the ELK stack because of the persistent volumes that we're going to create. There are some additional features that's related to the authentication API, such as a database, an ingress controller, and internet gateway, NAT gateway. All of these are useful but not mandatory. These are all optional. Well, internet gateway and NAT gateway are most likely recommended, but still the focus of this project is on the EKS cluster. So now let's go to the diagram of the ELK stack. This is what will be deployed in the EKS cluster with Terraform, along with an S3 bucket and some IAM roles. Let me go to the additional details. So first, let me explain a little bit about this. So what's inside here will be deployed to the cluster along with what I mentioned. So here is something like our authentication API, which will generate logs, and then beats from the Elastic Stack will capture those logs, send them to Logstash. Logstash will aggregate those logs, and then send them to Elasticsearch, which will index those logs and backup and restore on AWS S3. And then Kibana queries with Elasticsearch providing a user-friendly interface for this. And also I'm using the Elastic Load Balancer ingress controller, so it's easier to access Kibana, which just mentioning this is all in a private subnet, so we're gonna need this ingress controller to access those resources. All right, so now I'm gonna apply these resources, and when they have been deployed, I will come back. Also, I forgot to mention something, which are the detailed view of the resources. So these are all the resources that are going to be deployed by Terraform on the existing AWS EKS cluster, for example, and some extra resources such as IAM roles and S3 bucket, some Kubernetes resources such as the namespace, service account for IAM roles. The ELK stack will be deployed as Helm charts, a node group, the EBS driver add-on, and as I said, some IAM roles to allow Elasticsearch, for example, to access the S3 role for the snapshot and restore feature. So here you can see the deployment has finished. I had to run a Terraform script twice as it was deploying too many Elasticsearch tasks, and they didn't fit in memory, so I reduced it. Now let's see our Kubernetes resources. I'm going to open another terminal tab here. I'm going to type kubectl get pod and the name of namespace is monitoring. Here you can see the tests are running all right, one of each, and here you can see the authentication task, which is in the default namespace. Now let's go to our AWS console. Here you can see the cluster. No, that's not the cluster. This one is a cluster. And here you can see an S3 bucket, which was created with Terraform. It's empty right now, but later the Elasticsearch is going to do a lot of backup here. Let's see the load balancers. There are a couple ones here. This is the default one, and the second one is for the authentication API, and this one is for Kibana. So let's see. Let's try and paste here, and perfectly, we managed to connect to the Kibana interface. Now let's type our username and password that I have configured through Terraform perfectly. And now let's see some logs here. So analytics, discover. I have already created the log stash index here. So I'm gonna add filter. I'm gonna search for kubernetes.container.name is authentication API. Add filter. So as you can see here, you can already see some logs. I can validate that by typing here kubectl logs and then copying this huge thing. Here you can see this is one of the messages. So it's properly logging. Now let's filter by event.original. So here you can see the logs in a much user-friendly way. You can see everything that's on the kubectl logs command that I run. Everything is also here on Elasticsearch. So perfectly. Now I want to show an additional feature, which is the Elasticsearch snapshot and restore feature on AWS S3. So let's set it up here. Let's go back to home, and now you're going to scroll down under management. You're going to see stack management, and here snapshot and restore, we're going to create a repository, and here we're going to select AWS S3. Let's say test repository, then next. Here there's a bunch of configurations such as chunk size, buffer size. Here you can play with that, but I'm gonna leave all of them as default. I'm just gonna copy and paste the name of the bucket. So that's the name of the bucket, and then here, and then register. It's simple as that. And now we're gonna verify if the connection is alright, if we can connect to the S3 bucket. So perfect, it says connected. It means Elasticsearch has the permissions to do backups in this AWS S3 bucket. Now we're gonna create a policy, because we need policies to allow Elasticsearch to know when Elasticsearch should backup data on Amazon S3, because you don't want to do it too often, and you don't want to wait too long to do these policies, to do these backups. So let's create a policy here, and you're gonna see what I mean here. Let's do tasks, snapshots, and then here is a sort of schema for the snapshot. I'm gonna say like hourly snap now. So the name of the snapshots are gonna be hourly snap, and then a timestamp. Let me put a dash here just to make it prettier. So we're going to use our test repository, which is configured with AWS S3, and now we're going to schedule a frequency. So let's do hourly at minute. Right now it's 1846, so let's do it 1849, or actually 1848, so it's 1 minute faster. So in around now 1 minute, it's gonna start a backup. So right now we're gonna back up everything. Let's leave all of these options as default, and let's say an expiration time after 5 minutes. It doesn't really matter here. You probably want to set this a little higher if you're doing it in production, but here 5 minutes, it's okay. Now review everything, create policy, and soon it should send the backups to S3, and these snapshots are gonna appear, they're gonna show up here as they occur. So let's wait a little bit. If it takes too long, I might cut the video. Okay, perfectly. It was actually pretty fast. So we have updated. It's now 1848, and we have updated, and here we can see some files. So Elasticsearch is doing its backup here on S3. You can see you can't really tell much. It's mostly for Elasticsearch, and then with this data, you're going to be able to, let's say, you lost all your data. Then you have this backup. You can restore from this sort of snapshot. And here, let's see if the snapshot has been created. Maybe we should refresh the page. Yeah, so it has been created. Here you can see hourly snap, this date, and some unique identifier. So everything has gone all right, and that's it for this video. I hope you enjoyed this ELK solution on EKS. If you have any suggestions, please leave in the comments down below, and thank you for watching.